Well, hey there, kiddos, and welcome to your video on Transformations Day 1. It says at the top of your notes that this is changes of M. If you remember, M is the same thing as slope. So what we're going to be talking about today is what happens to our parent function. If you remember, our linear parent function is y equals x. So what happens to that parent function as I change the slope of the line? And we're just going to do some graphs, look at them, talk about what's changing, and then what happens to the lines, and then we're going to come up with some rules at the end. So you see this first little box, it starts with y1 equals x. Well, that graph is already on there for you. The parent function has already been put on the graph for you. The second one says y2 equals 2x. Well, if I want to graph that on my coordinate plane, what this 2x means is that I'm going to take every point from this line, and I'm going to double it. So I'm going to make it times 2. So there's two ways to do this. We can, in our head, multiply and make everything 2 times bigger and then graph it. We can grab our calculator, put in 2x, and get a table of values, or we can make a table of values. I guess that's 3 things, not 2. But I'm going to just walk through this. If you get stuck and you can't figure out what it is I just did, I promise you I'll go back and use the calculator for the second one so you can see how that works too. So the first point that we have on this line is 0, 0. Well, if I multiply that point by 2, it's still 0, 0, because anything times 0 is just 0. The next point, though, is 1, 1. If I multiply 1 by 2, I get 2, so the new point is going to be 2, 2. And then my next point right here is 2, 2 already, and I've got to multiply it by 2, which makes it 4, 4, because 2 times 2 is 4. So there's my new point, and then I can do this backwards. So I have -1, -1, which when I multiply by 2 becomes -2. And then -2, -2, which becomes -4. So here is my new line. I've just taken every point and doubled it. And so I'm going to connect those dots and make a line on my graph. And so now you have a new picture. You can see there's my new line, and we're going to label that y equals 2x because that's what line that is. And if you'll notice, my slope for this is supposed to be 2, which means I have to go up 2 and over 1. And so if you look, I go up 2 and over 1. I go up 2 and over 1. So that's definitely the slope of my line. So let's do the next one. The y3 is equal to 4x. So now what I've done is I have taken this first one, the parent function, and I'm multiplying everything by 4. So I'm making it 4 times as big. So again, the 0, 0 stays 0, 0. Because multiplying anything by 0 is 0. But then this next point, 1, 1, this one right here, when I multiply it by 4, it becomes 4, 4. So it goes way up here. Same with the negative one, it becomes -4, and I don't have room to put any other points on here. So I'm going to go ahead and connect those. And there's that line. Let's label it y equals 4x, so we'll know which line that one is. And now let's talk about what's changing. If you look at my equations here, this one has 1x, 2x, 4x, and so what is changing every time is the slope. And what is changing about the slope? It's getting bigger. I am increasing the slope every single time, so I'm making it a bigger and bigger number. And if you will look at my lines, and let's just talk about how they compare. This first one, the parent function, and then the y equals 2x. Well, the y equals 2x is steeper than the y equals x, and the y equals 4x is even steeper. And so how do they compare? They get steeper, because they are increasing at a faster rate. So now let's talk about the next little group where I have 1/2 x and 1/4 x, and we're going to do the same thing, except I'm going to show you how to, we're going to do this in our calculator. So if you've got your calculator, get it out and turn it on. If you don't, pause the video and go find it so you can get to it. But the y equals x is already graphed for us, so we're going to do y equals 1/2 x, which means we're going to cut all of our points in half. Well, we're going to use our calculator to do that. So we're going to grab our calculator, we're going to go to y equals, and in y equals we're going to put 1/2 x. So I'm going to do, and it doesn't matter, you can do 0.5 or 1/2, so I'm going to do 0.5 x. And I don't necessarily need to see the graph. What I need to see are points on that graph. So I'm going to press second and graph to get to the table, and you see I have points. Well, we're going to start. We can start with our -2 here. So I see my first point is -2, -1. So I'm going to plot that point on my graph. So -2, -1. Then I have -1 and -1/2. So I have to do -1 and -1/2. You have to estimate that a little. 0, 0 is going to stay the same. And then I have 1 and 0.5. And then I have 2 and 1. And so there's my graph. So I'm going to connect my points with a line. And then I'm going to label it so I know which line it was I was talking about. So this one right here is y equals 1/2 x. And so now let's do the 1/4 x. So I'll do the same thing with my calculator. I'll go to y equals, and I'm going to put, this time we'll do the fraction. So I'll go alpha y equals to make a fraction. And so I do 1/4, and then I have to hit the right arrow to get out of the fraction, x. And then I'll go second graph, make my table again, and we'll do the same thing. We'll start at -2. Well, -2, I'm at 1/2. So at -2, it's at 1/2. At -1, it's at 1/4, which is kind of hard to squeeze in there. Then it's at 0. Then at 1, it's at 1/4, and at 2, it's at 1/2. And so again, we'll make our line. And we're going to label it. This one is y equals 1/4 x. And so now we're going to talk about, what do we notice? What did we see? What's changing? Well, again, the slope is what's changing, but this time the slope is getting smaller because I went from 1x to 1/2 x to 1/4 x. And so my slope got smaller, and as my slope got smaller, you see my line got less and less steep. They got more flat. This 1/4 x is definitely flatter than the y equals x, and so they got less steep or flatter. Or more flat, however you want to say that. So now let's look at number 3. Number 3 has 4 lines instead of 2, or instead of 3, but we're going to still see the same kind of stuff happening. We're going to do what it asks, and we're going to graph them and then compare and see what's happening. So the first one, y equals x, is on there. That's your parent function. The next one is y equals -x, which just means I now have to change all of my signs. Well, 0 doesn't have a sign, so the 0, 0 will stay the same. But the positive 1, 1 is going to become -1, 1 because I had to change the sign. 2, 2 becomes -2, 2. 3, 3 is -3, 3. And 4, 4 is -4, 4. And then these points over here, the -1, -1 becomes positive. The -2, -2 does also. And so now what has happened is my line, it looks like, has turned the opposite direction. Because what I did was I changed all of the signs of all of my points. And so this one is y equals -x. Now we've already done y equals 2x before. We graphed it earlier. This next one, y3 equals 2x, we graphed it up here. It's where we just doubled all the points. So we're going to do that again. 0, 0 stays 0, 0. But the 1, 1 becomes 2, 2. And the 2, 2 becomes 4, 4. And the same thing happens with the negatives. And so there's my y equals 2x, just like we graphed it before. We'll go ahead and draw a line through those points. And then label it so we'll know what it's called. And then the last one that we have here is the y equals -2x. And so what's going to happen is I'm going to take my y equals 2x, and all of those are going to now change signs. So the 0, 0 stays the same, but the 2, 2 becomes negative. Sorry. I put that in completely the wrong place. Everybody pause 1 second. Alright, so now what's going to happen, I apologize for the needing to pause, what's going to happen is my points, just like with the y equals x, the points for the y equals -2x are also going to flip. So this one right here that's at 1, 2 is going to be down here at -1, or at 1, -2. And this one right here that's at 2, 4 is going to be down here at 2, -4. And then the same with these. These are also going to flip. The -1, -2 becomes -1, +2. And then the -2, -4 becomes -2, +4. And so my points just flipped just like they did before, except now that line is steeper than the original one. So this one is y equals -2x. So what I want you to notice, the thing that's happening with the slope, it's not necessarily that it's getting bigger or smaller. What's happening is I'm changing the sign. So for this one, the slope is what's changing and the sign is changing. It's going from positive to negative, and that's what I want you to look at, is what happens when I go from the positive to negative. So we're going to do the y equals x and the y equals negative x. So it's this one and this one. We're looking at these 2 points. So this line, the y equals x, is an increasing graph, but when I made it y equals negative x, now it's a decreasing graph, because what I did was I flipped the points. This point went from here to here, and so I flipped it over. The same thing happened with the 2x and the negative 2x. It went from increasing to decreasing because I took my points and I had to flip them. When I changed the sign, they flip. Well, if you'll think back to transformations in the 8th grade, hopefully you remember that the word that we use in math for flip is a reflection. And so what is happening is that when the slope is negative, the line gets reflected. And it gets reflected over the x-axis, but it gets flipped. It flips over, and so it changes direction. It goes from increasing to decreasing, and that's what a negative will do to your graph. So let's go to the next page. Now, without graphing, we're going to do number 4, but we're not going to graph them, because I'm hoping that you can go back to the first page of notes and look at what making the slope smaller does and what making a negative does. And so there's lots of things happening with here. But if I look at just y1, the parent function, and y2, I'm going from x to negative 1/2 x. Well, the negative, like we just learned, reflects the graph. The 1/2 makes it less steep. So when we're going to talk about what's happening, y2 is reflected because of the negative, and it is less steep. If I go from y1 to y3, all that's happening is I went from 1x to 3x, so y3 is just going to be steeper. Because when I went from a 1x to a 3x, I increased the slope and made a steeper line. Now, if I'm going to go from y1 to y4, because I'm always going to compare to the parent function. That's why we started with the parent function. Everything comes from the mama, so we always compare back to the mama. So the parent function, y1, and then y4 is negative 2x. Well, that negative, just like we said, is going to reflect it. The 2 will make it steeper. So y4 is reflected. I don't know why my F won't look like an F. Reflected, and this one is steeper. And you can graph them all and look at them, but that's what is happening. You have to know that a negative reflects it, a smaller number makes it less steep, a larger number makes it more steep. So now let's look at number 5, because now I'm changing the notation. I'm going from y equals x to f of x equals x. Well, remember that f of x and y are the same thing. So this is the same thing as saying y equals x. I've just changed the notation and I've made it f of x. Well, then my new function, instead of being y2, we're going to call g. So my new function, g of x, is 2 times f of x. Well, if f of x is x, then 2 times f of x is just going to be 2 times x, because that's what f of x equals. Well, so I'm really just graphing 2x again, which we've done already. And so we're going to graph our 2x. Let me go back to my blue pen, because that's what I've used for the second graph. So if I take and I do 2x, well, then I'm doing the same thing that I did before. I take my x at 1, 1, and I multiply it, and it becomes 1, 2. And then I take my point at 2, 2, and I multiply it by 2, and it becomes 2, 4. And then when I do the negatives, the same thing happens, only I have negative values. And so we've graphed this graph, only now our notation just looks different. I haven't changed anything other than the way I wrote it. And so the f of x equals 2x means multiply it all by 2, which just makes the graph steeper. That's what happens. So g of x is a steeper graph. That's what it's asking. Now, when I get to h of x, now h of x says that I want to do f of negative 3x. Well, if you remember when we do things like this and I do f of something, whatever goes in parentheses, that's what I plug in everywhere I see an x. And so this is really like saying the same thing as, instead of x, I'm going to put negative 3x. So I want to find the graph of negative 3x. So I'm going to do that very same thing. Well, remember the negative flips it over, And the 3 means multiply it by 3. So this first point would stay because 0, 0 doesn't move. Multiplying by 0 doesn't change it. But this point, 1, 1, when I multiply it by 3, becomes 1, 3. But then I have to flip it, so really it's 1, negative 3, because I have to multiply by negative 3. And then this point right here, negative 1, 1, when I multiply it by negative 3, becomes negative 1, positive 3. And so now it would help if I put it on the 3, not 2, 3. So now what I have is I have a line that has flipped over because my point's reflected just like you saw, and it is steeper than the original line. It definitely decreases faster than the first one. And so what I have is this f of negative 3x. So my h of x graph is steeper because of the 3, and it is reflected because of the negative. So those are the things that have happened. So now let's do a summary and talk about some things that we need. So now for 6 through 9, I have an equation, f of x equals 2x. I need to know how is that going to compare to the linear parent function f of x equals x. Well, we've talked about this. F of x equals 2x is going to be steeper because I made the slope greater. I made it a larger number. Now, how would the graph change if the 2 was changed to a 5? If I went from 2x to 5x, it would be even steeper than it was before, because 5x is definitely steeper than 2x. Well, what would happen if I changed the 2 to a 1/2? So now I have 1/2 x. Well, we talked about that before too, and if I make the slope smaller, then the graph becomes less steep. And so now let's predict what would happen if the slope of the function was changed to a negative 1/2. Well, we know what the 1/2 does. The 1/2 makes it less steep. The negative doesn't affect the steepness at all. All the negative does is it reflects it. So this one is less steep and reflected because of the negative. So there are some summary. Slope affects the steepness of the graph. So as I change the slope of the graph, I change the steepness. So if m is greater than 1, then I get a steeper graph. So as I make my slope bigger than 1, my graph gets steeper. If I make my slope less than 1, then I get a less steep graph. So as I get fractions and decimals, then I get a less steep graph. A negative does not affect the slope at all. All a negative m does is it causes the graph to reflect. So it causes a reflection. It flips the graph over is what happens. It changes it from increasing to decreasing. So that's what happens as we change the slope of a line. We're going to spend several days on transformations. This one was just what happens when we change the slope. And we'll talk more about all of this for the next several days, but we'll practice this when you come to class tomorrow. You guys have a good rest of your Sunday.